Okay, so we're going to go to, do I have the book stuff open? Great, that would be a no. 8.1 book. Sounds right. Okay, 37 you said? Okay. Does everybody have out the reference sheet and everything it said to get out? There's a pink reference sheet you need to have out. Are you have a pass or? All right, so this question about Kayla. Do you have your notes packet? There's extras right there by the blue basket. All right, Kayla's swimming due west. So here's some kind of a river and Kayla's swimming west. At 1.5 meters per second, a strong current is flowing south, off of south 20 degrees towards the east. So off of south 20 degrees towards the east is the current at a rate of 1 meter per second. Find Kayla's resulting speed and direction. We can do these as separate vectors and then add them together. That's why I didn't really draw them on one. So Kayla's swimming, or Kaya, I can read, wow. Totally did not see that there was no L. Is 1.5, and if we wanted to make that an angle, it would be 180 degrees. So you could do 1.5 cosine of 180 and 1.5 sine of 180. It's just going to turn out to be negative 1.50 because it's just going straight left. All right, then this one, we need an angle off of x for the wind. So we have the, or it's the current, sorry. The current, if it's 20 degrees towards the east off of south, that would be a negative 70 if I wanted to call it off the x. I have to make it into the fourth quadrant, so it's going to be negative. And it was just 1 meter per second, so it's 1 cosine of negative 70 degrees and 1 sine of negative 70 degrees. Anybody give me those numbers real quick? Cosine negative 70.34. Negative 9.4? Okay, now the resultant then is when we add those together. Okay, sorry, that bracket isn't looking good. If we add these two x's, what do we get? You get a negative in there, right? Negative 1.16, anybody? And then if we add the two y's back here, we just get negative 0.94. Okay, so how do we find the magnitude or speed? Pythagorean theorem. Magnitude or speed is just the square root of, I would just leave off the negatives when I typed, because then you don't have to use parentheses. So if you just type 1.16 squared plus 0.94 squared, and then square root that, I got 1.49. Anybody else get that? Or about 1.5. Well, that's what she was trying to swim. Well, the current didn't slow her down much, did it? All right, let's leave it 1.49 though. meters per second. Everybody got that, right? I didn't, not crazy? Okay. Let's see if it's knocking her off course, though. Inverse tangent of this resultant right here. So inverse, or just tan -1. I guess I don't need to write inverse. Of y over x, which is just going to turn out to be positive. 0.94 divided by 1.16. Yep, I got about 39 degrees. Now, this is in what quadrant? The resultant. It's in quadrant 3, right? We got to think about what's happening here. She's trying to swim west. The current's pushing her back this way. This is in quadrant 3. So she's really, we got an angle of 39 degrees here. But if we put it into quadrant 3, the 39 degrees would be there. So it would be south of west. Can we just say south of west, or do you want to go back to this kind off of south? Then we got to do some crazy. Yeah, let's just stick with, it's pushing her 39 degrees south of west. Like she was trying to swim straight west, but it's pushing her 39 degrees. Let me draw that a little bit bigger. But what happened is we got an angle here of 39 degrees, but it's really in the quadrant 4 here. Okay. Quadrant 3, thank you. Did I say 4 earlier? No. So it's 39 degrees here. So this is west, and it's going towards the south. All right. So it's pushing her way off course, but it's not slowing her down too much, which I was kind of confused by, but I think it's just because it's not very fast. All right. Going back to today's stuff, we are going to start with our learning targets today. I will tell you that this finding the component form is definitely on the quiz. Calculating magnitude and direction. Okay, we've already talked about this, but it's on the quiz. Basic vector operations is on the quiz. I don't think, and this is definitely on the quiz, right of vectors, linear combination, I don't think that's on the quiz. And unit vector is not on the quiz, but it's on the notes, and I'm just going to go over it really quick. All right. The idea here is that when you have two ordered pairs in, you have a vector that's going right 3 and up 2, right 3 and up 2, right. It could be anywhere, okay? And it would be equivalent. And so we could be given ordered pairs from anywhere, and if it went from O to P or A to B or whatever, we could find the equivalent vector from the origin, which is just component form. So what does it say down here? To find the component form of a vector that is not in standard position, you can use the coordinates of an initial and terminal point. So what we're talking about here is, if we have a vector that goes, let me sketch this real quick, -4, 2 is A, and +3, -5 is B. And we have a vector that goes from A to B, nice and straight like that. We can write its component form by saying what are the equivalent coordinates if I slid this to the origin, okay? All you're doing, guys, it says up here the definition is you're subtracting the x's from the second one to the first one and subtracting the y's from the second one from the first one. I don't even do that. I just think this is how far left it is and this is how far right it wound up. So what did it do? It went 7 to the right, yes? So you could do 3 minus negative 4 and get 7, or you could just think about what it did. And then up and down, it was 2 up and it wound up 5 down. So negative 5 minus 2 is negative 7. But I just think from negative 4 it went to 3. Okay, that was right 7. From 2 it went to negative 5. That's down 7. So 7, negative 7 is the component form. Okay, and then from there you can find the magnitude and the angle. So this is talking about magnitude. You just do Pythagorean theorem after you found that. So here's the example you have on your worksheet for example 1. It said 2, negative 3, and it wants from x to y. So it went from 2 to negative 4 for the x, which would be left 6. Everybody good? And negative 3 to positive 2 would be up 5. So those are the components. How do we find the magnitude? This should really be up here. How do we find the magnitude? We just do Pythagorean theorem on that vector we just found, negative 6 squared, 5 squared. Okay, because what we've done is take this vector and slide it to the origin. Equivalent vector would be left 6 and up 5. Just slid it to the origin, the tail. All right, so we get 36 and 25. Is that 61, guys? Square root of 61. Anybody want to give me a decimal? Okay, that's it. Does this feel like we've already been doing these kind of? Okay. So find the component form and the magnitude real quick. Do we need to do all three? I mean, it would be 52 minus 12 would be 40. And then 33 minus 41 would be, is that 8, guys? I think so, negative 8. And then we'd do the magnitude would be whatever that is. 40 squared plus 8 squared is 1664, or approximately. Okay, thank you. All right, you want to do 2 or 3? Okay, so again, if you're doing it, you always have to do this. It's vector A, B, it says in the direction, so the order matters, is what I'm saying, okay? Because the opposite would have had negative 48, positive 8. You'd get the same magnitude, but it wouldn't be in the right quadrant, okay? So this one is negative 1 minus 2 and 3 minus 4. Or like I would say to myself, 2 went left 3 to become negative 1, and then 4 went down 1 to become 3. Everybody good? You're going to get the signs right? Okay, then just do Pythagorean theorem. I think that's square root of 10, isn't it? Which is 3 point something. Thank you. We good on those? As long as you remember to look at your notes. All right. The vector operations, it's going to be your favorite part of the quiz because these are not difficult at all. Given the component form of two vectors, you can add them by adding the x coordinates. We've already done this, right? This is how we did wind and plane. We added them, added the x's, added the y's, okay? You can also subtract vectors, or you can multiply through by a scalar, just like when we did matrices, okay? So the first one, for example, 2 says add these two vectors. You would literally just add 4 plus negative 1 would be 3. And back here, 2 plus 3 would be 5. Everybody good? This one's done for us. It said if you had to do, they asked for this, 3 times s and then add t, you would take the s vector and multiply each part of it by 3 so that it's 3 times as long in each direction. And then you would add the t vector and get this. So let's try a couple quick examples. The first one is a subtraction. I'm going to write the vector down so we have a little more to go by. It says f is 4, -2, and then we're supposed to subtract g, which is 24, 21. Now, if you're not comfortable with that, you could rewrite it as add the opposite, if that made you feel better. Do you know what I'm saying? If you're worried about forgetting to distribute the negative, you could make this -24, -21. Okay, but you get -24 minus 24, and -2 minus 21 would be -23. This is just equivalent to this. Any questions about this? Is pretty easy, yes? All right, then there's a complicated one. It says take g. Did you have a question?
Yeah, will I ever ask?
It could at the end, but I don't think it does on the quiz. But yes, you could find the magnitude at the end. It says minus 2f. Can I write down 2f? What is 2f, guys?
Oh.
I was just going to double this. Is that okay? 8, -4, and then plus 3h. If I write down 3h here, it would be what? Okay. Now, do you want me to distribute the negative and then add, or you want to that make you feel better? Me too. Distribute this. Okay. So now we have 24 and -8, which would be 16, and -3, which would be 13. Anybody else getting that? Or am I crazy? 21 plus 4 is 25 minus 9, 16. Okay. Was I right? Those are going to be your favorite question on the quiz? You can handle those? Okay. All right. Unit vector, like I said, is not really something that's directly on the quiz. A unit vector says if you had a crazy vector like 3, -2, okay? So it is currently going right 3 and down 2. So here's the vector we're talking about. If you wanted the exact direction of that, but you wanted to shrink it down to be only 1 unit long, okay? You want to shrink it down to be only 1 unit long. Right now, how long is it? Nope, it went over 3 and down 2, so the actual magnitude of this vector right here is square root of 9 and 4, 13. Square root of 13 is the length of that vector. Okay, if you wanted to shrink it down so it was exactly 1 unit long, what you'd have to do is divide all of that by square root of 13. So you would divide this by square root of 13 and this by square root of 13, and you'd get 3 square roots of 13 over 13, and -2 square roots of 13 over 13. And this would now be exactly 1 unit long in the same direction, okay? And here's the rule for that. We are not going to have this on the quiz, so I'm just going to go through this one with you real quick. It does mention that this can be written in this notation, and that's the next thing we're going to talk about. You're going to love that part too. But for right now, we want to just change this to a unit vector. So it's currently going 4 left and down 1. So the vector is here. And it's going -4, -1. If we want to shrink that down so it's 1 unit long in the exact same direction, all we need to do is divide by the magnitude, which would be what? Square root of 17. So we'd have to divide each of these components by square root of 17, which would be a lovely -4 square roots of 17 over 17, and a -1 square root of 17 over 17. You glad I didn't put that on the quiz? Not that it's hard, it's just... Everybody okay? So we're going to do one more example. I think you have to skip a section of the notes. Can you go down and find number 7? I'm not going to do 8 just because it's not in the quiz. And I'm going to do this one because it's easy. If you go over 4 and down 3, what magic happens, guys?
5.
This vector is 5. So if we want to shrink it all down so it's only 1 unit long, we want to divide everything by what? 5. So the unit vector, which they call u, would be 4/5, -3/5. So what it would be is it would go over 4/5 of a unit and down 3/5 of a unit. And then if you calculated this out, this would become 1 when you did Pythagorean theorem on those little tiny numbers. Okay? Don't need it. All right. But this IJ business, like I said, you're going to like this. But if there was a vector that's named I that is 1 unit to the right, anytime you're going across, you can use an I vector of 1 unit. J is the unit vector that goes up, so it's 0, 1. These are called standard unit vectors. So if we have a vector like that's going 2 units to the right and down 4, it can also be written as 2 I vectors minus 4 J vectors, because that's it. This is to the right and this is up, and we made it negative. It's just called a linear combination when you write it like that. Now, it says don't confuse, the I vector is not square root of -1. Okay. I don't think this is on the quiz either, though I kind of wish it was because it's easy. This is called the linear combination of vectors I and J. So be careful. If you had an ordered pair here, if we had vector DE, remember what we did when we started today? If it went from -2 to 4, that's to the right 6. Everybody good? And if it went from 3 to 5, it went up 2. So if we had to write that vector as a linear combination or an IJ vector, it would just be 6i plus 2j. Loving this? This easy? Okay. So go down. This one's done for us, isn't it? Okay, go down to 9 and 10. Okay, what's 9 going to be? If you're going from n to n, remember, if you were doing it as a subtraction, you would have to subtract in the other order. Whoops. I'll just write one out so you remember. Yeah, from 2 to -5 would be left 7, and from 8 all the way down to -3 would be down 11. So how are we going to write that as an IJ vector? -7i minus 11j, or plus a -11j. I don't care. Same thing. That's it. Easy peasy. So one more. 0 to 18 would be 18. And 6 to 4 would be -2 though, right?
Yeah.
Okay. So if you wrote that as an IJ, you would write 18i minus 2j. Honestly, don't think I put that on the quiz. I probably should have because it's easy, but.
Can you? Add a little question.
It's just one more section, and then if you make a mistake, it's one more thing you made a mistake on, right? Find the component form. Okay, I need to back up and show you this example, but find the component form. We already know how to do this. Does this look familiar, guys? V cosine of the angle. Okay, so it's magnitude, cosine of the angle, magnitude, sine of the angle. There are some that they want to do exactly, and I don't care unless it might be a multiple choice question on the quiz, and then you got to pick out the right choice. So what do I mean by exactly? Well, this becomes 18 cosine of 240, 18 sine of 240. Grab your unit circle. Haven't looked at that in a while. What is the cosine of 240? And what is the sine of 240? Square root of 3 over 2. Did I get it right? Oh, yeah. I was in the wrong quadrant. Everybody good? So exactly, instead of typing that in our calculator, we use the unit circle. So negative 1/2 times 18 is going to be negative 9. What's this going to reduce to, guys? 18 divided by 2 is 9. There's a negative square root of 3, so it's negative 9 square roots of 3. Everybody okay? Just don't type the square root of 3 in your calculator, and you can do it on your calculator, but you want it as an exact answer. What if it's one you can't do from your unit circle? Yep, just type 5 cosine of 95, 5 sine of 95. Yep. We're going 2 decimals on this. We'll go 2 on that, whatever. Any questions? Easy peasy. So just watch. If it is a nice angle on the homework, do it exact just for practice. But I think the only one that's like that on the quiz is like a multiple choice or something, okay? So that you know to pick the exact. All right. On the previous lesson, we also learned that you can, once you've found the components, so you have a vector that says this, you can find the angle by doing inverse tangent b over a. That's all this is saying. Does that seem okay with everybody? We did this yesterday. So if you had a vector 3i plus 7j, it's really just 3, 7. So you do inverse tangent of 7/3 and you get this angle. Quadrant 1, no trouble, right? What quadrant is this in though, guys? 4, -5. Quadrant 4. So when I do inverse tangent, I get -51.3. Is that in quadrant 4? It actually is, right? -50. So it's okay to leave it, or you could add 360 and get 308.7. I don't care. All right, so let's practice because these are tricky when they're not in the right quadrant. Can we just do these two and then we'll do the one on your worksheet? What would you type? Inverse tangent what? I didn't bother to write it out, but it would be -6, 2. So we'd put 2 over -6. What quadrant is that in, guys? -6, 2 is in quadrant 2. So we need an angle that goes into quadrant 2. But when we type that on our calculator, the calculator doesn't know any better. And it gives us -18 degrees. Yep. Yes, we just need to add, it's in the wrong quadrant, so we just need to add 180 to it to move it around to the right quadrant. So if we add 180 to that, (161.6 degrees, and that puts it in the right quadrant to go with a negative positive, okay? So you always have to be careful that it's in the correct quadrant. Negative, negative, this one is in quadrant 3. Is the calculator, when you do inverse tangent of a negative over a negative, it's going to become positive and it's going to think it's in quadrant 1, right? So what are you going to have to do? How do you move something from quadrant 1 to quadrant 3? Add 180 again, yep. -8 divided by -3 turns out to be 69.4 degrees. But this was a quadrant 3 angle, so we need to add 180, which is 249.4. So you just need to make sure that it agrees with the quadrant. So we have these two. Can you do these two on your own? This is -4, inverse tangent, 2 over -4. Whoops. No, I can't write. What quadrant should we be in for 13? Quadrant 2. So when it gives us, what did it give you? -26.6, did someone get? That's not a quadrant 2 angle. How do we move it to quadrant 2? Add 180. It will give you the right quadrant if it's a quadrant 1 or 4 angle, yes. Because inverse tangent, do you remember when we colored our unit circle? Inverse tangent was colored in 1 and 4, okay? But everything else wasn't, and so the calculator doesn't know that it's possible to be in those other quadrants. All right, and this one, this is a quadrant 1 angle, so it gives us the right answer, but it's kind of a big number, isn't it? Inverse tangent, 17 over 2. Yeah, 83.3 degrees. I was just thinking that if you go over 2 and up 17, you're really close to 90 when you draw that in, right? So it's 83 degrees. Okay. Any questions? All right. Excellent. We made it. 1, 5, 11, 13. There's quite a bit of homework. It's all on 3.5a. 53 has stars here. I'm thinking that's because we need to do it together. It's actually an application of adding vectors. So let's do that. Can you find it on one? What did I just say it was on? 3.5b, I think. It's on 3.5b. Number 53. You find it? Okay. Anybody help me figure out the vector for the plane? The components? Yep, 600 cosine of 0, 600 sine of 0, which is just going to be 600, 0. I should probably write out. Okay, what about the wind? The wind is blowing 85 miles an hour, so that's our magnitude, at an angle of off of south 59 to the east. Do we do 85 cosine 59 and 85 sine 59? It always has to be the angle off the positive x-axis. So what is that angle? Kind of. Yes. If we put 31, it's going to think it's going north of east, right? It's going south of east here, so we need a negative 31. So we have 85 cosine of negative 31 and 85 sine of negative 31. Oh. Oh, okay. Yes, we're good. I thought I was not reading directions, but this is what we're supposed to be doing. Okay. I got 72. Did someone else get 70?
I got
2.9 and negative 43.8. Okay. So this is what the plane is doing. This is the wind pushing it. Now what? The actual speed of the flight is what happens when they're combined, okay? The plane is flying, the wind is pushing it, so how fast is the flight moving? We need to add those. And the resultant will have components, what, 672.9 and negative 43.8. Now, how do we find the speed of that? Pythagorean theorem. So 672.9 squared plus 43.8 squared, square rooted. $674.3, anybody? What is that? Miles per hour. Okay. So the plane thinks it's flying 600, but from the direction of the wind, could you tell it was helping it some? Okay. It's helping it not 85 because it's not blowing directly behind it, but it's helping it 74 miles an hour because it is pushing it a lot. All right, then the angle. If we do inverse tangent, what numbers are we using? Yes, the resultant. Inverse tangent, negative 43.8 divided by 672.9. I got negative 3.7 degrees. Anybody get that? Does that make sense for, right? We had a quadrant 4. Okay. So we have some options. If we wanted to do it south of east like they did, it would be a lot south of east, right? It would be almost directly east. The question on the quiz, guys, says how far off course is the plane being pushed? So if the plane's trying to fly directly east, how far off course is it being pushed? Yeah, 3.7 degrees, right? So I'm just going to say 3.7 degrees south of east, okay? The book would probably do 90 minus 3.7 and say off of south, it's flying 86.3 degrees towards the east. But this makes more sense to me because it's just 3.7 degrees off course. And that's what I ask on the quiz. I give you the plane, and it's either going north, south, east, or west. I give you the wind. You have to figure out the angle off the x-axis and its components. But in the end, all I ask you is how far off course did it get pushed? So I didn't make you do a directional thing, okay? Because we've included the direction in saying south of east, we don't need the negative, okay? I wouldn't worry about it. I'm not going to count it wrong. You got the right idea. But the direction took care of that by putting the words. Okay. Do you want me to do some more off worksheet 2? Because that's the icky stuff. Anybody? Or 1.5?